Hi everyone. I have one more part of section 12.3 to teach to you. So what we're going to talk about is trying to find the sum of an infinite geometric series. We're only able to do this when the common ratio, the absolute value of the common ratio, is less than 1. If you think about it, if the common ratio was bigger than 1, our numbers would be getting larger and larger and larger. So we would not be able to calculate the sum because the numbers would be approaching infinity. And the limit does not exist. Okay, so that's what I have for you right here. But when the absolute value of our common ratio is less than 1, we can use this formula, that the sum equals the first term divided by 1 minus the common ratio. And notice that we don't have a number here because we're not trying to find the sum of 1 or, a 2 or 3 or 10 of the terms. We're trying to find the sum of all of the terms. Okay, and it's an infinite series. So let's take a look at this problem. It says a rubber ball is dropped to the floor from a height of 27 feet. If the ball rises at each rebound to a height that is 2/3 of its previous height, we have to find the total distance that the ball would travel. So, first thing we have to do, we're going to write our formula. So our formula is that the sum equals a sub 1 divided by 1 minus r. And we know that the first height was 27 feet. We know that the common ratio is 2/3 because it's rising only 2/3 of its previous height. So we're just going to clean this up. 27 divided by 1/3. Of course, you know, when we're dividing by a fraction, we can multiply by the reciprocal. And what we discover is that the ball will travel a total of 81 feet. So that's just one example of, this formula and this scenario. The next example is if we have a repeating decimal, and we want to write this number as a fraction, which, by the way, sometimes we call it a ratio of relatively prime numbers. Okay, you'll see that from time to time. So what we have to do is we have to think about, forget about the 12 for right now. That's not repeating. What we're really focused on is the 981 repeating. So the first term, and I like to do these as fractions, 0.981 is actually equal to 981 1/1000ths. Okay? And because we have these three digits that will repeat, okay, the common ratio will be 1/1000. Okay, so when we have, this is how I think of it. When we have three digits repeating, we have a 1 with 3 zeros, 1/1000. So let's look at this. Again, we're going to forget about the 12 for right now. Okay, we're going to think about our formula. We're going to substitute in. So our initial value is 981/1000. And in the denominator, we will have 1 minus 1/1000. We're going to try to clean this up. So first thing I would do is I would take this 1 and I would turn it into 1,000/1000. Now what we have is 981/1000 divided by 999/1000. Okay, so we can look at this a couple different ways. First of all, we can multiply by the reciprocal, or what you'll notice is that the denominators here, the 1,000, 1,000, are both going to drop out. So again, I'll show you multiplying by the reciprocal would look like this. So you can clearly see that those two would cancel out. So what we wind up with is 981/999. And now what we have to do is we just have to reduce that. So, you can use your calculators, or even if you couldn't, you could say, all right, I know these are both divisible by 9. Okay, you might have thought 3, you could do your different tests or whatever. but we would find out that this turns out to be 109 over 111, which means this number, 12.981 repeating, is actually equal to 12 and 109 over 111. Okay, so let that sink in for a second. Think about what we did. We had three numbers repeating, so we had 1 over 1,000. Okay, we combined our terms here to give us 999 over 1,000. The 1,000s canceled out, and there we go. So let's try another one. So the next one, again, we have 6.27 repeating. So again, we will write that our first term is 27 over 100, because that's 27 100ths. And because we have those two digits repeating, our common ratio is 1 over 100. That's how we would get the next 27. And if we multiplied again, we'd get the next 27 and the next 27 and the next 27. So let's look at this formula. A sub 1 over 1 minus r. Our initial term is 27 over 100. We're going to divide that by 1 minus 1 over 100. Okay, just like the previous problem, we'll make this 100 over 100. Okay, and if you take a look now, we get 27 over 100 divided by 99 over 100. You'll probably start to find efficiencies with this formula, by the way, because you probably already know these 100s are going to cancel out. We wind up with 27 over 27 over 99. And again, we have to figure out, how can we reduce this fraction? 3 goes into both of these numbers, but even better, 9 goes into them. So 27 divided by 9 is 3. 99 divided by 9 is 11. So 6.27 repeating is equal to 6 and 3/11. Okay, so hopefully that made sense. Take your time on your homework and have a wonderful day, everybody. Bye.